Hi, I'm Kate Abshire, a hydrologist in the Water Resources Services branch at National Weather Service headquarters. I'm excited to show you today the ways we are using, producing, and sharing environmental data to advance flood forecasting and water resource needs in the United States. Flooding can occur when rain falls over several days or when intense rain falls over a short period of time. After heat, flooding is the next leading weather-related killer in the United States. It can occur in any part of the United States and its territories nearly every day of the year. Forecasts of water in our streams and rivers is essential for reducing or avoiding flood dangers and costs and for management of the nation's water resources. That's why the Weather Service is constantly trying to innovate and improve our forecasts, warnings, and impact-based decision support services for the protection of life and property and enhancement of the national economy. From the science of forecasting to the communication of flood hazards to our partners and the public, environmental data is crucial in helping move us forward. In order to produce this forecast data, forecasters and hydrologists use a lot of information and data sources. Forecasters and hydrologists use information from satellites and radar to gain awareness of current and recent conditions. Data from precipitation and stream gauges, temperature, snow, and soil moisture measurements all feed into models that provide a representation of how water will move into and through streams and rivers. All of the data that is collected and used also often becomes data flowing out. This information may be turned into products and services, with weather offices issuing watches or warnings to the public or supporting partners in their decision-making. To make decisions when a flood is predicted, there are three key questions that might be asked: when, where, and how much. Those questions seem simple, but you'll see there are a lot of ways they could be answered. First, we might consider precipitation. The river forecast centers apply quality control to radar estimates of recent precipitation each day. This data set is very valuable to understand where and how much rain has fallen in the past 24 hours. The information can be used as input to models, to compare against other sources of precipitation measurements and estimates, and it can also be used to compare to normal values for a location. Areas that have seen more rain than normal may be more vulnerable to experiencing flooding in the near future. Another key data set is precipitation frequency studies known as Atlas 14. This is a statistical analysis of how frequently rainfall of a certain depth or intensity falling in a certain period of time might be expected for a given location. This information is used in defining building standards for infrastructure design and development, and also in estimating the severity of historic rainfall events. If you've heard that the amount of rain that fell in a storm event was characterized as occurring on average once every 100 years, for example, this data set is where those statistics come from. When you think about heavy rainfall, one of the flood hazards that first comes to mind is flash flooding. Flash floods can be incredibly destructive and dangerous and result in loss of life. When a rapid rise of water into a normally dry area is expected within minutes to hours, a flash flood warning is issued. This warning contains information about the where and when of the forecast flooding, as well as text information about the expected impacts, the how much. To increase the data available with flash flood warnings, in 2020, machine-readable tags were added to describe the source of the information, additional expected rainfall, whether the flood is caused by a dam or levee failure, and the severity of the damage threat. These tags are already being used to allow automated monitoring and notification of these short warning events. For example, the damage threat tag is used for activation of wireless emergency alerts on your cell phone, limited to only the warnings where considerable or catastrophic damage is expected. For flooding on rivers, the river forecast centers generate official forecasts at approximately 4,000 gauge locations across the country. This series of forecasted water levels or flow amounts through time can be used as raw data by partners, but is perhaps better known through charts called hydrographs. This is a prime example of how to visualize water data to show someone the when, the graph runs forward in time, the where, the graph shows the location of the gauge, and the how much. The graph gives the value of flow or river height, and also the severity of forecast impacts, all in one single image. Similar graphics have also been used to show probabilistic information from the Hydrologic Ensemble Forecast Service. This takes the single line of how much through time and expands it to depict a range of possibilities based on short and long-range weather forecast scenarios and also on known climatology at that location. This probabilistic information is available at over 3,000 locations nationwide. While these thousands of forecast locations provide excellent information in and around the areas where they're located, most of the country doesn't have this type of forecast information. The need for guidance away from official forecast points is more critical as we live and build more near rivers and streams. In recognition of this need, the National Weather Service has deployed the National Water Model, a framework that simulates observed and forecast stream flow at over 3.4 million river miles throughout the United States, including Hawaii, Puerto Rico, and the Virgin Islands. It runs in multiple configurations with different atmospheric models used over different timescales as input to short, medium, and long-range forecast model configurations. It's so large and complex that it is required to run on a supercomputer to provide streamflow and other hydrologic variables. This information complements the official forecast points with high-resolution guidance along all the nation's waterways. From the very beginning, the information from the National Water Model was developed as data services that could be shown on a map. The where is nearly everywhere. The first services focused on timing, when, and magnitude, how much, but active efforts are working to expand the information available. Some of the other prototype visualization services include high water probability, streamflow anomaly, and rapid onset flooding probability. The key goal of these visualizations is to take the large volume of data coming from the model, summarize it, and visualize it on a map to show flood location, timing, and magnitude in understandable, easy-to-use ways. There may be no better example of this than flood inundation maps. Inundation maps visibly connect the flood forecast with the place, homes, businesses, and other landmarks. Being able to see the representation of the extent of water across the land surface illustrates the possible impacts of a flood in ways that charts and graphs can't. The valuable street-level information provided with these maps allows planning ahead of a flood event for emergency managers to improve their ability to pre-position equipment and resources, secure critical infrastructure, and recommend evacuations and evacuation routes. Inundation mapping using the National Water Model stream network was first formally demonstrated in Texas in 2019 and in Rhode Island and New York in 2021. This is now being rolled out operationally across the country with a goal of making them available for 10% of the United States population beginning in 2023 and increasing each year thereafter. This is a major advancement in our flood services and will be coupled with more work to refine our science and methods, train forecasters, educate partners in the public, and apply feedback about how best to present this information to decision makers. For information to be used, it has to be accessible. Even as we continue to build and improve our data sets and services, we are making it available for researchers and data scientists to use and better understand, to allow everyone to provide feedback to us for future enhancements. I'd like to take a minute to run through some of the sources for this data. Raw data from the National Water Model is accessible in near real time through the NOAA Operational Model Archive and Distribution System, or NOMADS, and through the cloud service provider platforms as part of the NOAA Open Data Dissemination Program. The NOD also has historical model data from prior runs of the National Water Model to simulate the last 40 years, taking into account information about actual measurements of precipitation data and Earth system information. National Weather Service official products, like our watches and warnings, are available as Common Alerting Protocol, or CAP, messaged through the NWS Application Programming Interface, or API. Weather Service official forecast information, like precipitation forecasts and excessive rainfall outlooks from the Weather Prediction Center, as well as National Water Model data, are also available as Geospatial Information System, or GIS, web services that follow the Open Geospatial Consortium (OGC) standards for web services. A REST services page lists all of the available web services. Those are all great if you have the technical know-how to reach them, but we also recognize that not everyone has the ability to start from scratch with these data sets. The National Weather Service National Map Viewer provides a single location to view a multitude of web services visualized on a map. For more targeted information, water.weather.gov is the main portal for river forecast information. Select National Water Model visualizations can be accessed from the Office of Water Prediction webpage at water.noaa.gov. These visualizations and a number of new experimental products are linked from the Office of Water Prediction Operations page. At the same time, we are building the future online home of the Weather Service's water information, the National Water Prediction Service. Launching in spring 2023, the National Water Prediction Service will be an interactive, mobile-friendly, integrated spatial display, which will include river gauge observations, River Forecast Center forecasts, National Water Model stream flow guidance, a hazard overlay, and precipitation estimates, among others. This one-stop shop for all Weather Service water resources information, including forecasts, data, and water services on the web, will be available at water.noaa.gov when fully implemented. Data is driving flood forecasting forward in the National Weather Service like never before. Thank you for coming to my NED Talk. If you have any questions or want to learn more, please reach out. I look forward to connecting with you.